Hey everyone, welcome to this week's Azure Infrastructure Update. It is the 7th of November and it's the week after Ignite. So this week I'm going to try and cover all of the key Ignite announcements related a lot around the Azure infrastructure kind of space. There is the Ignite book of news that goes into all of the details and links to fantastic blogs. So I've got that in the description below. As always, if this is useful, a like, subscribe, comment and share really is appreciated. And please hit that bell icon to get notified of new updates. Now, before I get into that, I wanted to just say thank you because we hit 80,000 subscribers. So that's obviously a huge thing. And I really, really appreciate all the support for helping me kind of get to that number. I'm going to do another Ask Me Anything session. That's going to be on the 10th of November at 8 a.m. So again, if you're subscribed, you can kind of go and see that. And again, the link's here, so you can go and join me. Bring your questions, just have some fun. As always, I've got the chapters to all the different updates we're going to cover. Kind of you can click on them right below there, or they're in the description as well. These are just kind of the high level ones because I just can't fit them all on the screen. But again, if there's particular things you're interested in, you can jump to that. You don't have to go and sit through the whole video. So new videos, I did a near 4-hour AZ-104, the Azure Administrator exam cram. So I already go through all of the different content. And to go with that, I created a playlist that's built off of my Azure Masterclass, but also added in some other videos to really fill out and give you as much information to help you take that certification. So let's get to the new content. So from a virtual machine perspective, they announced some new V5 SKUs. So this is both the DV5 and the EV5. So these are based on the latest generation Intel Xeon, the 3rd gen. And there's about a 15% increase on performance, up to 96 virtual CPUs. There's also a kind of DA and an EA, which is built on the AMD kind of EPYC processors, again, the 3rd gen. For both of those, they have kind of versions with and without temporary storage. Remember, the D series is kind of general purpose, so a pretty even balance of CPU and memory. The E is a more memory intensive, so a bigger ratio of memory to those virtual CPUs. E is very good for like databases, for example. Now, when I think about databases, they also announced this EB V5. And what's happening here is these new SKUs, they're in preview. So they're built on the same kind of 3rd gen Xeon processors, but these are actually going to deliver kind of like a 300% increase of storage performance over kind of the EV4. So if you think ordinarily about how we get the different types of resource. So ordinarily I could think, hey, if I had the idea of kind of CPU and memory, and then storage, IOPS, and throughput, the line kind of goes like that. What they're doing for these kind of EB series is the storage is going up much, much bigger. Because if I have kind of database workloads, hey, sure, I might need the E series for the higher memory to CPU, but I actually need more storage throughput and IOPS than I get even with the E series. So the whole point of these EB versions is they're going to have much higher IOPS and throughput. You might say, well, there's the L series. Why don't you use that? Well, the L series, remember, also has that local NVMe storage. Maybe I don't want that. I just want higher IOPS and throughput. So the biggest EB5 is actually going to be able to go all the way up to like 88,000 IOPS and I think it was 2,500 megabytes per second. But that was, I think, for the E32 they talked about. But I think the very biggest size they're making available, they've talked about 120,000 IOPS and 4,000 megabytes per second. So just a single VM will be able to go up to that, which actually is going to match the new UltraDisk maximum throughput. So huge, huge IOPS and performance possible there. They also announced the DC V3 series. So remember, the D series is all about that confidential computing. It has that Intel SGX, the software guard extensions, that lets me write applications to hook into that secure enclave. And the big deal with these v3 versions is that enclave page cache, the EPC, is actually 1,500 times bigger now. So I can have applications with much bigger amounts of that secure enclave memory. I think they have like 12 times the amount of regular memory, up to 48 cores. Things like Azure Kubernetes Service will also be able to leverage this. There's a new VM selector. So the VM selector is all about an experience where, hey, I can actually go in, because there's so many different VM SKUs. Well, what one should I be using? So now you can kind of go in and say, okay, I want to do it by workload type, by OS and software, based on certain regions. And then it's just going to ask you different questions. And you're going to go through this experience, and it will help you pick the right type of virtual machine. Also, so we now have the VMSS Flex has gone GA. So remember, the point about this is a virtual machine scale set is always about before it was uniform. So the point of VMSS is, hey, I have this virtual machine scale set, and with the uniform option, which is kind of what we were used to, we had some kind of template, we had some configuration, and we could have kind of manual or auto scale, and it would just kind of stamp those out. Well, with the new flexibility, this flex option, what we now have is kind of some of the benefits of availability sets, availability zones, but I just go and create this flex, and then what I can do is I then go and add VMs into it. Now the benefit here is with the uniform model, those VMs are all the same SKU, the same template, everything else. With the flex model, I can mix and match. I could mix Windows, I can mix Linux, I could mix pay-as-you-go, I could mix spot virtual machines. And because it's regular VMs, I can still get direct access to those individual VMs I add into the flex. But again, I get some of those benefits around, hey, availability set, maximizing over fault domains, even long-term availability zones. If I want this idea within of stamping out instances, I can actually, within my flex, so I can mix it, I can still create a VM profile. So a VM profile can still be, hey, some template, some configuration, and it can then go and stamp those out as well, combined with the VMs I'm just kind of manually adding into it. So this VMSS Flex option is really cool. I'm now kind of getting some of the benefits and the best of both worlds. So that is now generally available. I go and pick the option I want. Hey, do I want the uniform model we're used to, where they're all the same? Or I can now do the Flex model, where I can add VMs into this set, but still also I can have that profile if I want to. Automatic guest patching has gone GA. So this is for Windows and Linux, and it's built around critical and security classified patches. It runs every couple of days. It follows the normal availability first principles. So if I've got paired regions, it's not going to do it at the same time. If I have availability zones, it's AZ by AZ. And based on the region, it's going to try and do it in off hours, check in success rates, etc., etc. But now for those Windows and Linux, I can get a very easy guest patching experience. And then trusted launch has gone generally available. So if I think about Windows, I have that idea of, hey, measured boot and signed boot, etc. Well, now it's bringing this to my Azure virtual machines as well. From the bootloader to the OS kernel to drivers, it's kind of checking the signatures of all of those components. Now, because I'm using that idea of like measured boot that hooks into hardware, it has to have a virtual TPM. So I have to do this in a generation 2 Azure virtual machine that gives me that UEFI base and that virtual TPM. But then at time of creation, I can turn on trusted launch and get that validation of that entire process. Again, I was talking about Windows, hey, secure boot and measured boot, but it does also apply to Linux virtual machines. And here it talks about the VMs that are supported for this and the operating systems that are supported as well. And I think it probably does talk about the virtual TPM and the Gen 2. So there we go. It mentions the whole idea of, hey, I have to have that Gen 2 VM for this to work, which is why it's only certain virtual machine SKUs, kind of the newer ones, that have that UEFI base option, so we can actually leverage it. So Trusted Launch now GA. And Azure Automanage has a number of improvements. So this is that idea that, hey, it's IaaS, but I almost want that PaaS-like experience in terms of me having to do things to the operating system. So what they're really building is there's all these different services in Azure, like the patching, like backup, like configuration. So it's really building on those. So I have now things like, hey, for those virtual machines and Automanage on Azure, hot patch. That ability now to reduce the number of times I have to reboot, I can just apply the patches and hot patch it into the OS so I can apply them quicker because I don't have to find a time I can reboot. Things like for secure file access, it's SMB over QUIC, QUIC. So QUIC provides an alternative to TCP. It basically creates this encrypted tunnel over UDP port 443, which is very nice over the internet. So now I can do SMB over untrusted networks. There was things like preserve on-premises IP address. This uses kind of these Windows Server 2019 instances on-prem and in the Azure VNet that creates this bidirectional VXLAN tunnel that now lets me take IP addresses and have that same space defined in a virtual network, and I can kind of bridge that gap. So a whole bunch of nice improvements there. AKS now has NAT Gateway integration. Remember, NAT Gateway is all about that outbound traffic and doing that snatting. It has lots of IP address, so we don't get port exhaustion. Well, now as part of my AKS provisioning, I can also provision and configure NAT Gateway. That can really be useful if I was using like a standard load balancer for my ingress. Well, by default, if I don't do outbound rules, I can't get to the internet. Well, now I could use a standard load balancer for my ingress and define a NAT Gateway for that internet-based egress. Saves me having to configure it manually. Azure Service Operator v2 has gone GA. So when we think about, hey, Azure resources, AKS is obviously Kubernetes. It's great for having my deployment YAML file to deploy things into my Kubernetes environment. But often there are Azure things as well I want to complete the solution. So what this Azure Service Operator does is let me actually create Azure resources via my YAML deployment file that I send to Kubernetes. So it gives me a really nice seamless provisioning experience. So what this V2 has, it has improvements around faster support of new resource types that get added to ARM. I can view the state of resources in Azure. I get a nicer view of the resource state, new dedicated storage versions, and a bunch of other stuff. But really, this is all about letting me create Azure resources through the deployment YAML files I send to AKS. Also, when I talk about this Azure Service Operator, it's now super simple to deploy via VS Code. There's essentially now this extension that I can use in VS Code. I give it the service principal, and I can get that deployed out. I can now stop and start node pools. So AKS has had that ability to stop and start the cluster. Now I can actually do it for individual node pools. In the past, what we would do with node pools is I would scale it to 0. But then I've kind of lost the configuration I had, like how many instances there were. With this, I can stop it, and then when I start that node pool again, it's back to where it was before I performed the stop. So I'm not losing any kind of configuration or status. This is via the AKS node pool start command today. DAPR extensions are in preview. So I'm actually going to talk more about DAPR in a second. So DAPR is this super interesting thing, really when I'm designing microservices. And when I designed microservices, there were things I want. Secrets, a stateful store, service discovery, network features, traffic splitting. There's all these different things that maybe as the app developer, I don't really, that's not my expertise. So DAPR brings this great portability and abstraction for me. I can have different parts of my microservice written in different languages. It abstracts it all away to a set of standard HTTP gRPC, remote procedure calls, but a new modern, very high performant version. DAPR does all that for me. So now, through this extension, I can get that provisioned onto my AKS cluster super simply. So now my developers can start building on top of DAPR which just runs as a sidecar on AKS, so it's another container in my pod, and I can start using those standard means. I don't have to worry about all the little implementation details. And then there's the secret store CSI driver has gone GA. So that's the container storage interface through which I can create many, many different types of interaction. With this, now my secrets, my keys, my certificates in Azure Key Vault can be exposed to my Kubernetes environment, just like it's part of the file system. So again, it abstracts me having to know about AKS or how I interact. I'm just viewing it like any other part of the file system, which greatly simplifies all of my interactions. Open Service Mesh add-on went GA. So Open Service Mesh is built on kind of that CNCF Envoy solution. So again, that's another sidecar in my pods, and actually DAPR hooks into this as well. And what I get is a lot of very powerful capabilities around my networking. Again, if I think about microservices in my environment and needs I have, I might want to encrypt the traffic between them. I might want to change routing for a subset of the traffic, maybe kind of like blue, green, or A/B splitting. I might want rate limiting. I might want to allow traffic, block traffic, mirror traffic. Well, I get all of that with this Open Service Mesh in addition to great telemetry and actual insight into it. So this gives me, again, another really easy way to get that deployed into my AKS environment. There were also updates around sort of J2E, Java Enterprise Edition on AKS, WebLogic, WebSphere Liberty. So you can go and check those things out as well. So on to more general compute. So CosmosDB has a new connector for Logic Apps. So with these connectors, it makes it very, very easy to do things like triggering. So hey, the CosmosDB changelog has something written to it. I can go and trigger a Logic app in addition to binding so I can perform other types of operation against it. All of these are super, super high performance. And then they announced Azure Container Apps. So Azure Container Apps is kind of a super interesting, and this kind of brings a lot of that kind of DAPR and other things together. And I'm just going to talk about this in a little bit more detail than maybe some of the other things. So if I was to think today about containers in Azure, so remember we have some idea of a registry. So we have a container registry and we have some image. Now obviously I need to run that in something. So at a very simple end, we have things like Azure Container Instances. So I can create multiple Azure Container images that are going to run that image. So it's an Azure Container Instance, it's a instance of a container. It's running in kind of this hidden managed VM, it's kernel level abstraction, but it's kind of dealing with them one at a time. I could create 4 of them, but I'm doing all of those actions kind of manually. At the other end of the scale, we have things like Azure Kubernetes Service. So we have this very powerful Azure Kubernetes Service. It has kind of that management control plane that's just done for us. It has things like the API server. And then what we have is a whole bunch of nodes. So we have a whole bunch of nodes. It has things like the kubelet that talks to that API server. There's certain amounts of management and understanding I have to have with that. Now we get great features like the horizontal pod autoscaler. So as pods, maybe there's different types of triggers. Hey, I can scale those things out. I can also do a cluster autoscaler. So I can modify the actual number of nodes I have. But there's a certain amount of knowledge I need to have. Hey, I can even actually use ACI through a virtual kubelet. But if I'm designing like microservices and I want like a serverless, a true serverless, but with some additional functionality, well, this is where this brand new, we'll use the universe pen. You know, I say that for special occasions. We have this new idea of these container apps. Oh, that was weird. Let's go back to that. So I have this new idea of my container applications. So this is now all about, hey, I just have these microservice deployments I want. So what I actually do with container apps is I have the idea of an environment. Now that environment deploys to a virtual network. It has its own log analytics workspace. And then within that, I could absolutely just create regular containers. I could absolutely just have the idea of, hey, I have some app revision, and it has a certain number of instances of that container. It has built in things like Kida. So Kida is all about that, hey, I want to do these kind of auto-scale type capabilities. So I can think, I've lost my board again. So I can think about, okay, I want to do this event-driven auto-scaling. It could be it's based on maybe a number of requests coming in. I could think about it's an endpoint type service. Maybe it's an event-driven service. So hey, I want to do it based on some kind of QDev. Maybe it's just performing some background processing, so it's based on some kind of resource. So there's different ways I can scale. But I can scale from 0, i.e. it can scale to 0. It's a true serverless option up to some maximum I specify. So I could just take a container, I can run it in this thing. I could use Kida, it's optional for the scaling. But if I think about, hey, I'm really creating this microservices solution, remember I talked about all those challenges we faced. So what we also get with container apps, in addition to Kida, that Kubernetes event-driven auto-scaling, is we get DAPR, this distributed application runtime. And that's what adds all these features like the publish subscribe, the secret store, the persistent state management, binding to other types of service storage out there, helps service to service communication. I might have another part of my service, kind of this app 2, that has its sets of things that are scaling independently. Well, DAPR makes it easy to talk between them, to discover. It will automatically encrypt between them. I can do the traffic splitting. And again, I just have these standard HTTP, gRPC-based methods of communication. That's just part of container apps. It's built on Kubernetes. Behind the scenes, there's Kubernetes, but it's completely hidden. It's abstracted away. This is just now providing me this fantastic experience that I'm just going to deploy revisions, so I can have multiple revisions, i.e. different versions of the image, maybe offering a change to my API spec, multiple revisions running within here, and I don't worry about Kubernetes. It's a complete serverless solution that has the great things like Kida and DAPR and Envoy just natively available to it. So that is now obviously in preview. You can go and start playing with that. But I think this is going to be a huge thing. And they did a really good article, and I've got it linked below, that kind of talk about, hey, ACI versus container apps versus AKS versus app service, and kind of the benefits and where they really play and where I might want to use one potentially over another. So you can go and check that out. But I think this is going to be huge when we think about all the microservice stuff we actually have happening right now. ACR connected registry for IOT Edge. So if you think about the Azure Container Registry I just drew about images, well, IoT is obviously really powerful that I have things maybe on-premises somewhere else, and I have things in that container registry. Yes, they can be container images, but there's other types of OCI artifacts that I might have in there as well. So this connected registry, I can essentially synchronize down to a local registry, so some edge registry that I can then use through the things in my edge environment. So it's a great way to, on some schedule, to synchronize the objects that can then be used by my local IoT Edge resources for their deployments. Azure App Service now has regular diagnostic settings. So just like other services now, app services, I can easily send different types of log to storage accounts, Event Hub, log analytics, etc. ASEv3 now supports Windows containers. Remember, ASEv3 is that dedicated deployment of an app service. There's no shared components. It goes into your virtual network. The great thing about the V3 is it's kind of this magical hidden network we don't see, but it uses that for all of its management purposes. So I can't break it anymore by adding UDRs or NSGs. The only thing going through my VNet is the actual application traffic. It performs faster. They got rid of the stamp fee, and now we have Windows containers as well. And then Logic App enhancements. So there were a whole bunch of changes. There's an improved kind of design experience. The flow, the arrows have got kind of better information. SQL Server is now a standard storage provider. And there's a whole bunch of other features that you've probably seen across a variety of workloads where you kind of see this option to do a task. If I quickly just jump over. So if we just look at one of these things for a second, if I just really pick anything, if I look at, I want to find a storage account actually. If I quickly look at a storage account, and I can't remember what the icon for storage account looks like. Getting old. There we go, storage account. If I just go and look at a storage account for a second, and that's taking its time to load, then my other subscription will be faster. So there's a storage account. So often what you'll see is this tasks. So you kind of see this tasks automation. Now the exact task's going to vary depending on the type of resource, but this is essentially a logic app. I don't know what's going on. Everything's going slow all of a sudden. But for example, here I could have things like, hey, delete old blobs, and that's going to go and create that logic app for me. So there's these built-in things now for logic apps to actually go and leverage. Let's see if one of these loads a bit quicker. Of course, I'm trying to demo, so everything's going super, super slow. But ordinarily, you would see tasks. I don't know what is happening there, but it enables me to now go and easily create those kind of logic apps we actually have. So there you go. I can do add task, and it would show me the different types for those different types of resource, but I'm not going to sit and wait for that. I have zero clue what's actually happening today. It knows I'm doing a demo, so it's going to try and mess me up completely. Thank you. Oh, there we go. So I can select a template, and it would kind of carry on. Moving on. Azure Stack, and obviously Azure Stack has got a whole family of things. You've got Azure Stack Hub, kind of the big turnkey appliances, Azure Stack Edge, those kind of single unit things that have different characteristics. Some of them have GPUs, FPGAs, but it brings certain Azure services to the edge. It's on my premises. HCI, where it's multiple boxes running special versions of Windows Server and Hyper-V, Windows Admin Center, storage spaces direct, so it's hyper-converged using local storage, and then hooked into a lot of Azure services. And then Arc, obviously bringing Azure outside of Azure. So Azure Stack HCI now has Azure Virtual Desktop support in preview. So now if I have my HCI deployment, I can actually get Windows 10, Windows 11 based Azure Virtual Desktop running on that environment. And remember, one of the unique things about Azure Virtual Desktop is multi-session for the client OS. Multiple people connecting to the same client instance. I get that on this solution. And then they announced kind of vSphere and Azure Stack HCI Arc integration for VM. And I've got create delete, but it's actually a lot more than that. So I kind of talked about, well, brings Azure outside Azure. So if I think for a second, we talk about Azure. Oh, I'm not going to use my Universe pen for that. If I think about Azure, what is Azure? Well, Azure is really capacity. And then on top of that capacity, we bring various types of service. That could be a VM, it could be Kubernetes, it could be databases, it could be machine learning, it could be app services, kind of the list goes on. And when we think about Azure, well, it has kind of that Azure Resource Manager as that control plane. And then what Azure also brings is a whole set of kind of management capabilities. I obviously get things like tagging, I get inventory, I get policy. The list goes on. Backup, config, etc., etc. Security services. Well, now I could think, well, actually, you mentioned the word capacity. I have capacity on premises. And maybe in there I've got VMs, so I've got OS instances, that's Windows or Linux. Or maybe I even have some other cloud, an AWS or Google, and it has capacity. So the whole point of Arc is, well, you have this idea of Arc-enabled kind of infrastructure. So I can think about, hey, we have Arc now that brings these capabilities, hey, into OS instances. Also, I could have some CNCF compatible Kubernetes, or I can bring Arc on top of that as well. Then I start bringing these Azure capabilities like policy, like the security service, like the inventory, like the tagging. That single control plane now extends to my resources on premises in other clouds. I get things like GitOps. Hey, I can point this to a Git repo, and as I make commits to YAML files, it will pull it down and apply them. But then what Arc does is, well, once I've got this Kubernetes layer, then we get Arc-enabled services. So again, this could be in other clouds, it could be on-prem. Now I can get things like the database services, machine learning, app services, layered on top of that, again, in any of these kind of locations. So that's Arc. But what they're now adding is kind of this Arc-enabled virtualization. So now I could think about the idea, well, actually, I have that capacity is actually kind of vSphere, or it's Azure Stack HCI. And what now Arc is actually going to do is basically have this deployment into those environments, talk to those APIs. So now it can actually talk to the hypervisors, that virtualization layer, and through Azure, these environments will show up as custom regions I will add. So I can say, hey, in Azure, deploy a VM to vSphere in wherever my location is, and now it'll actually go and create the VM. Stop the VM, start the VM, delete the VM, change the configuration of the VM. That's now being brought actually to our environment in preview. So that's kind of that big announcement there. Arc Kubernetes Container Insights is now GA. So again, bringing those curated sets of views around performance of the hosts, the pods, nodes, all of those different things is now GA. So I can bring all those great insights and visualizations and query capabilities to it. And then HCI Arc-enabled by default. So I could think about, hey, if I have my Azure Stack HCI, Arc is just now going to be enabled by default on my environment. And Arc machine learning inferencing is available. So again, all these great services. On the networking side, so announced this kind of gateway load balancer. And obviously, if you follow me at all, you know I love the networking stuff. So this is a super interesting solution to a problem that's been there for a really long time. So if I think about network virtual appliances, so we had this challenge. So we had this idea that, hey, I have some workload that sat behind a load balancer, and it's maybe my application. Well, actually, I want it to go via some virtual appliance. So I would have my kind of NVA, and we want multiple of them, so we're resilient. Well, we would give that kind of the exterior facing, but it would also need an interior load balancer to get return traffic. And we had a lot of problems. We got a lot of problems because it was different load balancers getting symmetric traffic flow. i.e., if traffic comes in, well, I can't have it going this way in and then that way out. If they're stateful, it wouldn't know it. So we often had to kind of run this ugly active-passive thing. I had to have a whole bunch of user-defined routes. It was really not a pleasant experience. So what they've done is now I have my load balancer with my app behind it, just as we did before. This can be external. And what we're now going to actually do, and I'm going to use my universe pen, we're going to say, hey, we like this thing. I create this new thing. So this is now my gateway load balancer. And behind that, I'm going to have my NVAs. Now, I could have n number of these. These can all be kind of active, active, active. This could be built on VM scale sets. It really doesn't matter. I could think about this could be in a different subscription, even a different tenant. This is kind of the consumer of the service. This is my provider of the service. And what I'm going to do, I'm going to chain this to this load balancer. Now I'm drawing this as a load balancer. It could also be a public IP directly to some kind of VM. But I'm performing a chain. So now what's actually going to happen is, really cool, there's no UDRs. Just this chain action, the traffic's going to come in, and this is kind of a true bump in the wire. So this will send the traffic. These MVAs just have to understand VXLAN. So it's encapsulating, it's doing a VXLAN tunnel. It's encapsulating the traffic. This just has to decapsulate it to look at the original source and destination IPs, do whatever it's going to do. Maybe it's inspecting it, it might drop packets. Doesn't have to do anything else. Traffic will then just go back automatically. There's no routing I'm doing. And then it will go to some target. It's guaranteed symmetric flow. And that's all I have to do. There's nothing else, like there's no UDR. I don't even have to have a peering. This could be completely different VNet. There's no peering between these virtual networks required. It's all just going to be done by the chain. So this is super, super cool stuff. And it's completely transparent. Like the source and the destination do not know this was in the network path. It's a true bump in the wire. So this solves all of those challenges we had with network virtual appliances, trying to make them highly available. I did a whole video on highly available network virtual appliances. This gateway load balancer is really a game changer. And there's like 11 launch partners for this, but you're not restricted to those. You can absolutely, as long as you have some appliance that understands VXLAN, go nuts. That's really all that is required. Network Insights for VPN gateways and Azure Firewall went GA. So if I go to Network Insights, I now get improved visibility into kind of the flow of the resource topology. There's pre-built workbooks. There's direct links to documentation and troubleshooting, just things to help you. ExpressRoute FastPath has some improvements. Remember, FastPath is all about the idea that, hey, if I have ExpressRoute Gateway, normally ingress goes via that gateway. Egress never goes via the gateway. Just goes straight to the Microsoft Enterprise Edge at the MeetMe. But ingress goes via this gateway. So it adds a little bit of latency. So FastPath bypasses that gateway. So what's new is now traffic to peered networks also supports FastPath. So even if the destination is in some spoke network, I can still bypass the gateway now. So I still get those improvements. I talked about IPv6 private peering last week, so I've already talked about that. There's new ciphers and functionalities for MACsec if I'm using direct port for that over-the-air at the MeetMe kind of encryption. So there's some things around that as well. ExpressRoute private peering BGP community support. So remember, a community is just a custom collection of IP addresses. So what I can now do is I can create a custom community that represents my virtual network. So I have these groupings of IP addresses. I'm creating a community for the IP addressing of my virtual network. And what's now going to happen is through the private peering to my on-premises will now see that custom BGP community that I've specified for the VNet. So it could use that for routing, maybe for other types of filtering decisions. There'll also be a regional community added automatically based on the region of the virtual network. But I can now specify when I create the VNet or to an existing, a custom community, and it will now be seen from the on-premises gateway, and they can make various decisions on that. Bastion standard went GA. This lets me do manual scaling, I think from 2 to 50. Other things it gives you is an administration panel. I can enable, disable certain features. It supports RDP for Linux. It supports SSH for Windows. I can do custom inbound ports. So there's some additional functionalities added there. And Azure Virtual Network Manager has gone into preview. So if I think about virtual networks, with a virtual network, often, we talked about the idea, I have multiple virtual networks. Well, today I have to manually create peers between them. I might have to have network security groups, i.e. sets of rules to control the flow of traffic. So what this new network manager does is actually a couple of different things. For example, I can now pick a connection topology. So I have the idea, let's say, hey, I have a whole bunch of virtual networks. So what I can actually now do is it gives me the ability to create a network group. So that network group could be based on, I am manually adding them in, or maybe it's based on some value of a tag, some attribute. So I can kind of create kind of a network group, and then I can target that network group. I might say, hey, I want to deploy a mesh architecture. So it would create peerings between every single one of them. Or I might say, hey, I want to deploy a hub spoke. So it would kind of create those peerings. I can even say, hey, I want a hub spoke and I want to be able to use the gateway. So, hey, allow gateway transit, use remote gateway. But I also want to enable direct connectivity for these peers. So then it would actually go and create a kind of mesh relationship for those as well. In addition to that, we actually get the idea of admin rules. So I can also create admin rules. Now these look a lot like network security groups. So I could still have local kind of NSGs on these things, but I can also now define these admin rules and apply them to that network group. And these kind of apply first. It's not an override, but think of a filter. So these get applied first. So if I was blocking traffic here, well, it's going to block it. It won't go through. But if I was, for example, blocking traffic at the NSG, if I allow it at the admin rule, it's still going to get blocked at the NSG. So this is kind of a filter first, and then it hits the filter of kind of the local NSGs. So I could maybe have some admin rules set at a high level, don't allow offering port 80 out to the internet, for example. The other nice thing as well is, so the regular NSGs let me say like TCP and UDP. These admin rules also let me say AH and ESP. So there's some additional protocol options I actually get with these admin rules. But then again, I can create these admin rules centrally and then target network groups. So it's security and it's kind of helping me create all those peering relationships as well. So that's the idea around the Azure Virtual Network Manager. So that's in preview. You can go and try that out. On the storage side, so on-demand disk bursting for large premium SSDs has gone GA. So smaller premium and standard SSGs have kind of a credit-based bursting. If I'm running below my provisioned IOPS and throughput, I start to accrue credit that I can use for up to 30 minutes. Well, now the disks that are larger than that, let's say 1 terabyte and above, I can pay a cost to turn on-demand disk bursting. And then I just pay for basically the number of transactions I do beyond what's standard on the disk. So I can use as much as I want because I'm going to pay for it. I'm not time bombed, it's not 30 minutes, but it's not free. I can now go and actually turn that on. Remember, Ultra Disk, I have dynamic IOPS and throughput anyway, so I don't need that. Also remember, if it's going to be like maybe a shorter term window, with premium SSDs, I can also change the performance tier of the disk separate from the capacity. So we actually have a number of different options now around our kind of IOPS and throughput, that overall storage performance. Managed disks now have a live resize capability. So now for a data disk, I can actually make it bigger while it's connected to a VM and it's running. Now remember, once I change the size of a disk, I have to go into the OS and then increase the size of the volume on that disk. But hey, I can now dynamically resize upwards. You can't shrink disks. I can only make them bigger. Cross-region disk snapshot copy is now in preview. So managed disks, well, they're LRS or ZRS. They live within a certain region. I can't do GRS managed disks, i.e. an asynchronous replica to a paired region. And snapshots live on the same storage as the disk. So it's still not giving me a solution to get some sort of cross-region capability. What I can now do is I can create a job that will do a copy of a snapshot, it could be an incremental snapshot, it's only copying the changes to essentially a region of my choice. So I pick the region and it's going to go and do that copy to that other region. It does it as a copy start job. And it's per snapshot. So every time I create a snapshot, I have to go and kick off this copy process. I could write an automation to, hey, I see this has happened. Let's go and trigger off a new copy start job to copy that to the other region. But now I can get that kind of regional resiliency for my disk snapshots. Disk pool for AVS has gone into preview. I'm pretty sure I've talked about this before. I don't think this really is new. But this is the idea that I have my managed disks. I have my Azure VMware environment. So remember, that's running vSphere private clouds, but in Microsoft data centers. Well, now I can take my managed disks, I can expose them to those VMware environments. What I essentially do is I group my disks into a pool. There's now, what is in preview are kind of these changes, is I can have a high availability iSCSI target. So the way vSphere uses this is it connects over iSCSI, which is exposed via the disk pool. It's now supports standard SSDs. Before it was premium SSDs and ultra only. And there's a new pricing model. There's a new, excuse me, end-to-end portal experience. Central key management for disks. So if I was a bring your own key for the encryption of my managed disks, well, now I can actually have those keys in a central subscription, a different subscription from the disks themselves. So that's going to let me have a centralized subscription, ease the management, improve the security of the keys for those various disks. I still have to have the key vault and the disk encryption set. Remember, we apply the custom key to the disk encryption set and then put disks in the disk encryption set. Still have to be in the same region. I can't cross region for those things. And it has to be the same Azure AD tenant. Ultra disks have a new 4,000 megabyte per second throughput ceiling. So remember I talked about that new EB series VM, the EB5, and its biggest sets of SKUs will support 4,000 megabytes per second. Well, Ultra disk can match it. So I can now actually pump through 4,000 megabytes per second with those EB5s and the new Ultra disk limit. CosmosDB indexing metrics. So in addition to the existing query metrics, I can now actually use these indexing metrics to optimize the performance. So I could see both, hey, what indexes are being utilized, but also I could see, hey, these indexes are recommended. So I could say, hey, this is how I can actually go and improve my performance. I can now apply throughput spending limits. So we have this whole idea of this provision throughput for CosmosDB. Well, now at time of creation or afterwards, I can actually set a limit on what I want that throughput to actually be. So if I was to jump over super quick, if I go and look at, let's see if the performance improves for me here. But if I just go home for a second, and if I go and look at my CosmosDB, and I look at my little CosmosDB here, well, one of the options we have, remember, is kind of cost management. And what we'll now see is total throughput limit setting. So we can actually say, hey, I want to limit it to a certain amount. I can do no limit, or hey, what I'm actually doing is limiting it up to the 3. I'm using the free CosmosDB account you get per subscription. So you select that, and that's what applied that 1,000. It's basically the same thing. So it's limiting me now, so I can really control what my possible spend could be. So that's a really nice feature to control my spending. It now has a partial document update. If you think about CosmosDB, it consists of documents. And ordinarily in the past, if I was to update some part, it would do a complete write of the entire document, which obviously has a certain amount of time and overhead. Now, if I'm only changing a certain part of the document, well, that's the only part that's specified in the update request. It reduces my network throughput, reduces the overall amount of work being done. Server-side Cassandra API retry. So again, we have the idea that I have a certain amount of provision throughput, those request units. Well, if I'm exceeding that, what would happen in the past is it would just return a 429. Hey, you've exceeded, it would fail. What I can now do is on the server side, instead of failing, it'll wait a little bit of time and then retry the operation for me. So now I don't have to do so much work. It's essentially doing that retry for me rather than me kind of doing that in my code. And there's now cost-saving recommendations. So as part of CosmosDB, it's going to look at different things like, hey, based on my usage patterns in the past, it will recommend, hey, maybe enable auto scale if I'm using kind of just a provision throughput. If I'm using auto scale, hey, maybe I should go to manual throughput instead, because obviously you pay different amounts for provision versus the auto scale. So if I was super consistent, hey, auto scale is probably not the best option. Just have this provision throughput instead. Regular database. Azure SQL Managed Instance now has this link capability. If I think about SQL 2019 and SQL 2022, I can actually now link it very easily to Azure SQL Managed Instance. And what that gives me, when I do that link, it gives me this near synchronous replication, and I can actually do this kind of bi-directional replication capability. And they did announce SQL Server 2022 as well. But this link is super, super powerful just for the replication, but also for failover capabilities. Azure SQL MI has some performance boosts, so it can use the new premium series hardware, that 3rd gen Intel Xeon. I can get new memory per vCore as a memory optimized solution for the hosting. It supports 16 terabyte storage capacity now. And I can also do Windows authentication via Azure AD integration. So it gives me cloud support without having to change my actual code. Azure Managed Instance for Apache Cassandra went GA. So as the name suggests, this is just a managed instance of Cassandra. One of the nice things about this is it's running on top of VM scale sets. It runs into my Azure Virtual Network. But if I have an existing Cassandra ring, I can actually add this to it to get a nice hybrid solution. And flexible MySQL, should have wrote my there, went GA. So remember, flexible, these are the managed offerings, the managed open source offerings in Azure. So before it was single server, which is based on kind of this specialized container technology. Well, flexible is actually built off of virtual machines. It lets me use things like the B series so it can be burstable. I can stop and start them. It supports availability zones. I can optionally add a high availability option, so it has kind of an ongoing replica for an automated failover. So it really adds a lot of great capability there. So that's now for MySQL GA, not PostgreSQL yet. Azure Backup, it now has some metrics and metric alerts, some metrics around backup successes, metrics around backup failures, and then obviously I can trigger alerts off of those via the standard kind of action groups we have with alerting. But this multi-user authorization is super interesting. This is really powerful. If we think about ransomware, hey, we have backups. Well, the bad actor comes in and stops our backup or deletes our backups. So what we can now do with this is we create the concept of a resource guard. Now that resource guard can live somewhere else. And it's going to have a completely different people who actually have rights over that resource guard. So under no circumstance would my backup admins also own the resource guard. But I'll create this resource guard object, completely isolated, different subscription. It can even be a different tenant from where my backups are. I'll give the backup admins read access to that resource guard. And in the resource guard, I can actually see this. In the resource guard, I can configure to what types of actions it will actually apply to. So if I go in here super quickly, and if I search for resource guard, notice it's in preview. So I could go and create a resource guard. And after I create that resource guard, I can go and specify different things about exact actions it would apply to. But once I've actually gone ahead and created it, if I go and look at my recovery services vaults, if I just pick one of these, if I go to the properties, if I could see it, we actually have this option now of multi-user authorization. And we can then link it to, I don't have any, but I could say, hey, I want to protect it with a resource guard and specify it. So now what would happen if some bad actor came in and they managed to get a backup admin's credential, they couldn't stop the backup. They couldn't delete the backup because they're protected by the resource guard. To actually perform those types of operations, I would have to get contributor rights to the resource guard. So I might use privileged identity management, but the owner of the resource guard would have to grant me that and then revoke it after I've done that action. So it's the ability now to really protect my backups from some bad actor who compromises the backup admin. But again, it's completely useless if you make your backup admins own the resource guard. Should be a separate set of people, put it in a separate subscription, and have a good process to actually grant that only when those different types of actions actually have to be performed. Miscellaneous. So Azure Monitor action groups. Remember, an action group is the thing I can call to some kind of event that happens. A webhook, an Azure function, a logic app, email, SMS, whatever. Well, now I can also talk to Event Hub. So PubSub, other things might use that. Azure Monitor now has a log analytics workspace data export in the portal. So if we think about the whole point of that data export, I can get this continuous data export at a table level, so there's no filtering, it's just going to send everything. And I could send that hourly to a storage account or near real time to an event hub. Well, now through the portal, I can actually see those different rules and gives me insight. I can create, edit, whatever I want to do. Log Analytics Workspace Insights went generally available. So this is kind of insight into my insights. So if I look, for example, at one of my Log Analytics workspaces, just quickly kind of look at this. So let's look at my workspaces. So if I just pick, I think EastUS would be a good one. If I scroll down, I get my insights. And what I get through the insights is you can see, well, great information about the workspace. The volume, ingestion over time, what's actually happening, who's using it, the different types of health, the agents that it's talking to. I apologize for my dog. All of this kind of great information is now just available to me. So that's there and available, and that's GA. OpenID Connect, Azure AD, and GitHub Action is in preview. So before, GitHub Actions is all about kind of, hey, I'm doing some things. It could be part of a pipeline, but I can really trigger off many, many things beyond just some commit action. Well, if it wants to go and perform actions against Azure Resource Manager, i.e. create things or modify things in Azure, before I'd have to have an Azure credential stored as a secret in my GitHub. What this actually now lets me do is using the OpenID Connect, I can actually, as the GitHub, I can create an Azure AD app registration that represents the GitHub actions, and I don't have to store any credential. So it gets rid of that secret I have to store in GitHub, but now I can go and integrate with Azure resources through my GitHub actions. And Azure Automation Managed Identity went GA. So remember, Azure Automation, I can run PowerShell runbooks, Python. We used to have the whole idea of these kind of run as accounts. Well, now I can use managed identities. If it's a cloud runbook, cloud job, I can use both system assigned and user assigned. If it's kind of a hybrid, then I can only use a system assigned managed identity. But now within those runbooks, they can say, hey, give me the identity, and it can use that to go and talk to other things. Also, PowerShell 7.1, latest and greatest, is in preview for those runbooks. Azure Security Center and Azure Defender have now been renamed Microsoft Defender for Cloud. There was a whole bunch of, I think, renames around this, but now you'll kind of see that Defender for the cloud. And one of the big things they announced was this native AWS support. So now that whole cloud posture security management extends to AWS. I don't need agents. It's going to use the AWS native API to go and communicate. There's like 160 out-of-the-box recommendations across IaaS and PaaS and different regulatory standards for AWS. So now it will actually give me recommendations on that AWS environment and things like the AWS EKS, the AKS equivalent, Defender for servers. I get all of those kind of capabilities available as well. Azure Virtual Desktop Autoscale is in preview. I definitely have talked about this in previous weeks, but basically I can create this concept of a scaling plan. The scaling plan consists of one or more schedules. So different days of the week, times. I can have kind of an off-peak, a ramp up, peak, ramp down behavior. Am I deploying things kind of breadth, fill them up, or I want to kind of maximize usage of individual hosts? I can set all of those different schedules as part of the scaling plan, then link the scaling plan to a host group. So that host pool will then get those schedules and apply them. So again, I can optimize my kind of resource spend. For Windows 365, remember that's that additional offering to just give me a cloud PC. There's kind of the business for smaller environments and enterprise. Did a whole video about this. So the web client got enhanced. Faster load times, higher performance. I can bookmark cloud PCs, local resource settings, edit a whole bunch of different things. Enterprise now has native Azure AD join. So initially, it had to be able to integrate with virtual network and it had to be able to talk to domain controllers. Now I can just do Azure AD. I don't require the virtual network. I don't require domain controllers. I don't require kind of that Azure stuff. Business had some updates as well. I can be a user, a standard user, or a local admin. I can be Windows 10. I can be Windows 11. I can purchase and assign licenses and provision them all from kind of an end user portal. And then obviously when I do use Windows 11, I get all the Windows 11 enhanced security, the virtual TPM, the secure boot, the UEFI. There's a bunch of Windows 11 marketplace images. So all of that is there. And there was a huge Azure AD blog. It's linked below. I cannot cover it all. But the big thing was about resiliency. So Azure AD, obviously they increased their SLA to 4 nines. They have this whole cell-based architecture. So Azure AD is now made up of 107 cells. Even the biggest cell only accounts for less than 2% of all Azure AD traffic. So it was some failure. It should only impact a very small amount of Azure AD. So that cell is rolled out, it's there. Also, backup authentication is being expanded. So think of backup authentication as kind of the generator, a backup generator for Azure AD. Separate set of infrastructure. And it basically has stored some long-lived tokens. So if Azure AD is down, it can give out these long-lived tokens that it pre-caches by talking to Azure AD periodically. And it was really based around SharePoint and Exchange, but they're extending it to things like WebEx. So it's going to be able to use that backup authentication. There were new conditional access features like device filters, so I could target particular devices. There were app filters. So instead of having to specify apps in my rules, I could tag an application, and then if it has this tag, apply these particular conditional access policies. Workload identities, so I can actually now have conditional access for particular applications. Continual access evaluation continues to evolve. That ability to not just, hey, a token's good for an hour, there's nothing I can do. I could actually say, hey, I want to register. So if the user is deprovisioned, if their password changes, tell me, and I'll stop allowing that token. If the user location changes, hey, I can kind of check in and know and not respect that token anymore. So ability to make, what it lets me do longer term is have longer lived tokens. So I have to talk to Azure AD less normally, but it still react to things if they happen. There were new identity protection checks, things like, hey, token theft, anomalous tokens, session cookies, and I can export all those risk things via diagnostic settings. And there were a whole bunch of other token changes and SAML supports, and kind of check the blog article about that. But that was it. I know a lot of stuff. I tried to cover it as kind of briefly as I can, but still kind of make it useful what it's there for. Huge amount of work does go into kind of preparing these, so please like and subscribe. That's appreciated from me. Hope to see you at the Ask Me Anything. And until next time, take care.